Nuclear power, safer and less expensive. A workable plan. The greatest challenge with nuclear power generation is its safety. The nuclear reaction must be kept below 612 degrees Celsius at all times to prevent a core meltdown and corresponding disaster. The typical nuclear power plant consists of a core reactor with continually circulating cooling water. There is a missile-proof barrier of concrete surrounding the entire reactor. The circulating water is boiled from the heat of the nuclear rods, creating the steam that drives a turbine to produce electricity. Then, the steam is cooled and condensed back to water, and the cycle continues. Safety features such as cooling rods and redundant cooling systems are commonly used to prevent overheating of the core. NRC regulations also require passive cooling systems for new power plant construction. These enhancements in safety have driven up the cost of nuclear power plant construction and operation considerably. If these safety requirements could be enhanced with a simpler design at the same exceeding current regulatory requirements, the cost of nuclear power would be considerably less. We have a solution to make nuclear power generation safer and less expensive. Our solution starts with a simple premise. If the core was surrounded by an unlimited supply of cooling water, it would be inherently safe and less expensive to build and operate. We propose modifying the traditional land-based reactor design by removing the reactor from the land. In our patent, the core is constructed inside a floating barge, submerged below the water level. Built-in safety systems rely on basic principles of physics and chemistry, automatically flooding the outer structure with cooling water on increases in temperature and pressure. And in extreme cases, even the inner core can be flooded. With our design, built-in safeguards include a filtration system to capture steam from the core during cooling, separate cooling loops to separate the core from emergency cooling, and various other patented approaches for enhanced safety. If the core begins to overheat, the traditional method of inserting control rods would be initiated to stop the reaction, and the cooling system would continue to function and remove the decay heat. In the event of a larger failure, the following safety scenarios would play out. If an electric pump fails, the water will stop circulating in the loop and the core will heat up. When the core heats up, the outer chamber can be flooded with water. When the outer chamber is flooded, the heat from the core is harvested by the water around the core by the loops of coolant that circulate between the core and the flooded chamber. If the outer chamber cooling is not sufficient to stop the reaction, the core can be flooded too. If a pipe breakdown occurs anywhere in the circuit, then valves outside shut off and open the outer gates to cool the surrounding chamber. Similar to the previous scenario, the core is flooded, but exhaust valves are also opened. Once the exhaust valves are opened, the whole system is like a punctured balloon, assuring water steam is vented through the filter and not downward into the water supply. If a pipe breakdown occurs inside the containment chamber, the outer chamber would be flooded similar to the previous examples. The boiled water exhausts safely through the filtration system until the core cools down. To further reduce overall costs, we propose several smaller reactors on a fleet of barges. This assembly line production reduces costs to build and maintain our nuclear reactors. Barges can be towed to a single maintenance area for repair, and a new one replaced immediately with virtually no downtime in electricity generation. All spent fuel is removed via waterways to a single location for reprocessing. Barges can easily be placed in a safe shoreline with transmission lines transferring electricity where it is needed. A barge with two 250 megawatt reactors each would generate the equivalent of a 500 megawatt plant. Nuclear power, safer and less expensive. A workable plan.